Welcome to this video about integration by parts. So we already did the testing on the functions. We have now these two functionals which are equal, and now we do integration by parts to evaluate this spatial derivative. This means the term in front still remains the same. Then we apply this integration by parts to this derivative operator here, and then we get an additional surface term, and here in the surface term then there enters the Neumann boundary condition, and this is also why in the homogeneous form it's the natural boundary condition, because this just means that this term cancels out. And yeah, in this sense we now arrived at a continuous system with an infinite number of functions and an infinite number of solution points. This means this W and the pressure itself is built up on an infinite number of functions, and the domain itself is also has infinite solution points, but we still have some additional things done already. Considering the strong PD, the acoustic pressure must satisfy second continuous space in time in space, and the test function itself must not be that much continuous, because we don't have to build any spatial derivatives. But here now the weak form, in the weak form we now have to compute gradients on the test function and also gradients on the acoustic pressure, but we more or less shift the degrees of freedom somehow, in the sense that we now are able to lower or weaken the requirement on the acoustic pressure. And this is why we are in the weak form. As I mentioned already, in the surface term, now the Neumann boundary conditions, or the ABC as the radiation boundary condition, or simply an impedance boundary condition enters, and this is how we connect now boundary conditions and this weak formulation. Thank you for watching this video about the continuous weak formulation, and we will in the next video continue our derivation to the finite element formulation.